Hi everyone, and welcome to the Unit 4 Day 7 video on sum and difference formulas. We use sum and difference formulas when we are required to simplify a trig expression at an angle that isn't found on the unit circle but can be created by the sum or the difference of two angles that are on the unit circle. So for example, 75 isn't on the unit circle, but it's the same as a 30-degree angle plus a 45-degree angle, which are both on the unit circle, so we could use a sum formula for that one. So anyway, you just need to copy these formulas down. They are also going to be on your formula sheet. You do not need to memorize them, although they are condensed into a single formula. So for the sign of the sum or the difference, it's written with a plus minus sign here and a plus minus sign here. The tricky one is cosine, which is written with a plus minus sign here, but notice in the cosine formula, within the actual formula, it's the opposite sign of whether it was you were using a sum formula, you would subtract your expressions within the formula. If you were using a difference formula, you would add. And so the way it appears on the formula sheet is within I don't really know how to say it. Like this part of it is a plus minus sign, but then within the formula, it's got a minus sign on top and a plus sign on the bottom, which basically just makes you remember that it's the opposite sign within the formula. And then, of course, the tangent formula would also be condensed, and the sign on top is the same. So if they match here, then you'll see the plus minus sign above. But here where the signs are opposite in the denominator, you would have the minus plus sign, the minus sign on top. So anyway, you'll see what I mean when you get your formula sheet, but please be aware of that. Okay, so here's how we'll use it in an actual problem. Okay, so again, let's say you had to find an angle that's not on the unit circle, but it can be composed of the sum or difference of angles on the unit circle, like -105. We could calculate it as the difference of 30 minus 135, both of which are on the unit circle. So then we apply the formula, in this case the sine formula, because that's the trig function we're given, and then we just evaluate on the unit circle. So sine of 30 is 1/2, cosine 135 is negative square root of 2 over 2. Cosine 30 is square root of 3 over 2, and sine of 135 is square root of 2 over 2. We multiply, and then we subtract. And because these have common denominators, we don't even need to find a common denominator. We can just subtract our numerators. And just keep in mind that you cannot incorporate these into the same square root. You can only add or subtract radicals if they have the same radicand or number inside the radical as well. So that would be as simple as we can make this problem. If you get a decimal answer, that means that you haven't simplified, or that you've put your answer into the calculator, and that's not going to be accepted. I'm only accepting simplified radical answers. A second example involves radians, which can be a little bit harder because sometimes it's harder to see what angles on the unit circle you need to use. But 7 pi over 12 could be broken into 3 pi over 12 and 4 pi over 12. And 3 pi over 12 is pi over 4, which is on the unit circle. And pi over 3 is 4 pi over 12, which is also on the unit circle. And then we could apply the cosine formula, again making sure that in between we use the opposite sign on the than the one that was given in the beginning of the problem. So just make sure that you are paying attention to your signs. That's the biggest thing. And then we just evaluate as usual. The cosine formula takes the cosine of both angles and then subtracts the sine of both angles. So we get square root of 2 over 2, 1/2 minus square root of 2 over 2 times 3/2. When we multiply them, we get square root of 2 over 4 and square root of 6 over 4, and then we subtract them again. They already have a common denominator, so we just need to subtract our numerators. So we get the square root of 2 minus the square root of 6 over 4. It looks kind of messy, but that's your final answer. So jot down any questions that you have and make sure that you come in next class and we'll get them cleared up for you. In class, we'll do an example of tangent. The formula for tangent you can see is a little bit more complex, so we're going to do that one in class so the video doesn't get too long. And if you want credit for watching this video, right now, please send me an email with a picture of the notes that you took and the questions that you have for next class. Thanks, guys. See you then. Bye-bye.